Don't forget to subscribe and ring that bell.
Why, hello, my friends. Welcome back. That was creepy. It's a free response question number 3 of the 2015 AP Calculus AB exam. And we don't get a calculator. I'm sorry, that was a gasp, like that dude on the left side of the screen here. He's got bags under his eyes. He just wants this to be done. He is working hard. He is just as stunned as I was. But you know what? Let's get this done. Let's get this AP Calc AB exam out of your life, at least for now. And let's get a 5 on it. But first, it all starts at free response question number 3. Let's go. Number 3 says, oh, oh, we have a table. I love tables and graphs and charts. We have a hey guys, we have a table. Peter, we have a table. That's my Joe Swanson impersonation. I'm sorry if it got loud there for a second. I do voices, but I don't really do them that often on the thing here. It's a work in progress, children. Anyways, oh, I love tables. Let's dive right into this. Problem 3 reads, Johanna, jogs. Joanna jogs along a straight path for time between 0 and 40 inclusive. Joanna's velocity is given by a differentiable function v for Visca. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table. I love it above. 3a says, use the data in the table to estimate the value of v prime of 16. First of all, children, in order for me to find the velocity, the derivative of velocity, right at one point, which is 16, a time of 16 minutes, I need an equation to take the derivative of. I cannot do that. 16 would happen to fall right in between 12 and 20. So that's why they tell us to estimate, because we can't find it exactly. So what I'm going to do is I'm going to take the two closest coordinates where time is 12 and time is 20, and I am just going to do an average rate of change. That's a change in y being my velocity, over a change in x, my x being time. That's all I can do to estimate, and that's all I have to do. So y2 is 240 minus y1, which is 200, over x2, which is 20. Oh, wow, what did I have, a spasm there? What the heck happened? Minus x1, which is 12. Now, don't be scared, kids. I know we don't get a calculator, but that's 40 over 8. That's not 90, that's 40. I don't know what's wrong with my writing. I got to go see a doctor maybe. Who knows? I'm kidding. I don't. That's 5. Do I need a label? I don't. But, and the only reason I am going to address this is sometimes they tell you to give a label. And I just want to reiterate that these are my y's over my x's. The labels would follow numerator and denominator. What do I mean? My y is meters per minute. That would be on top, meters per minute, over my x label, which is minutes. So it's meters per minute, or you could say meters per minute squared. Or you can be smart and not write anything here because it doesn't ask you for this problem. I only went over it because there are problems, especially when they're this simple, where they expect you to put the label. 3b, using correct units. If you watched 3a, I just spoke about this. Correct units. Explain the meaning of the definite integral, the integration from 0 to 40 of the absolute value of vt dt in the context of the problem. That means we're going to have to mention Johanna. and her jogging, and maybe something about minutes or meters per minute. But in the context of the problem means we got to talk about this woman and her addiction to jogging. All right? So after we do that, after we explain the meaning of that integral, they're asking us to actually approximate the value of that integral using a Wright-Riemann sum, which we lovingly call an RAM. Okay? And they want us to do that with the 4 subintervals indicated in the table above. All right. So first of all, let's talk about what this means. And let me take a minute to pull away and state that we have absolute value bars here. If I integrate anything, any function, without absolute value bars, that means displacement. That means if I start at one point, even if I go all the way out here and I turn around and come back and I end up here, they only care about displacement, the distance from where you started to end. But if you put absolute value bars here, okay, they want every single, I got to total this all up. Okay, that means I got to add all of these. That means this distance is positive and this distance is positive. Okay? If I was just doing this integration without absolute value bars, this would be positive, and then I would subtract this. That's how I would get this distance. But in our case, we do have the absolute value bars, so everything should be considered positive. All right, so it is a total distance moved, not displacement. It doesn't matter if we went right or left, we count everything. So let's first start by answering the first part. The integral from 0 to 40 of the absolute value of dt represents the total distance Johanna jogged. I know that's jogged. Between time equals 0 minutes and time equals 40 minutes. That's it. Not only did we answer this first thing correctly, I mean, we aced it. That's the first part. Now let's look at the second part. We got to approximate this value. We're going to use an RAM with the 4 subintervals they gave us. So the first subinterval goes from 0 to 12. That has a width of 12. The second subinterval goes from 12 to 20. And that has a distance or a width of 8. The next one goes from 20 to 24. That only has a width of 4. And last but not least, ooh, it's a pretty sherbert. From 24 to 40. That's 16, friends. Now, I got to handle, because these are all different widths, I got to handle each rectangle as I'm doing its own individual RAM. So for the blue, I'm taking the right value of the blue, yep. I'm taking the right value of the blue rectangle, which is 200, and multiplying it times its width, which is 12. So it is 12 times 200. But don't forget, everything should be positive. So I'm going to do this. And that's 2,400 plus. Okay, let's take a look at the next one. We have the green rectangle. The right output or velocity is 240 times the width, which is 8. So we have 8 times 240. But I also want to make sure that's positive. That's 0, 32, carry the 3, it's 1920. The red rectangle, the right side is negative. Remember, we want everything to be positive. Times the width, which is 4. So I'm going to say 4 times my negative 220 but I want this positive. So it's going to end up being a positive 880. Plus, last but not least, Sherbert time. We have 150 times 16. Oh, you guys. 16 times 150. Absolute value. We do 150 times 16. 6 is 900. My 150, that's 2400. All right. All right. So we are at a point where we just got to combine all these things now. 24 and 24 is 4800. 20 and 80 is another 100. And 1900 and 800 is 2700. 0, 0, 6. Okay. 7,600. Do they ask us for a label? They do not. If they were asking us for a label, remember, this represents the total distance. Ooh. Should I have set the total distance in meters? Can't hurt. But this would be in meters if they asked us, but they didn't ask us. So we ain't going to tell them. We so smart, kids. Okay, halfway done. On to 3C. Bob. Hey, Bob. Bob's riding his bicycle along the same path. Bob, I think you should jog a little bit because Joanna is in much better shape. She's jogging. You are just biking. Not to take anything away from biking. People who bike, that's more than I do. But I think jogging gives you more of a cardio than biking does. I get it. You can make the argument. Let's just do some math, kids. Bob is riding his bicycle along the same path for time between 0 and 10 inclusive. Bob's velocity is modeled by B of t, which is t cubed minus 6t squared plus 300, where t is measured in minutes and B of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. Guys, I mean, come on. If I know velocity, acceleration is just the derivative of velocity. So acceleration equals the derivative of Bob's velocity, which is the derivative of t cubed, 3t squared, minus the derivative of 6t squared, that's just 12t, plus the derivative of 300 is 0. But I don't even got to write that. And I want this at a time equals 5. I mean, 3 times 5 squared is 25. It's 75. Minus 12 times my 5, which is 60. I mean, this almost seems like it shouldn't be a 3C problem, but it is. Do we have to put, we don't even have to put a label. If it's acceleration and velocity is meters per minute, this would have been meters per minute squared, or you could have said meters per minute. But we don't need either one because they didn't ask us for it. It's hard to believe we're done, but 3D and we're done. Based on the model B from part C. Okay, if I go back, my model B of t was t cubed minus 6t squared plus 300. Let's go back and make sure. Yep, there it is. T cubed minus 6t squared plus 300. Okay. Find Bob's average velocity during the interval from 0 to 10 inclusive. Let me take a moment to talk about something that feels important. When it talks about average, in 3A, we did an average rate of change. An average, I'm going to just say ROC for rate of change. That is y2 minus y1 over x2 minus x1 all day long. They will say 98% of the time average rate of change when they expect you to do that. Or, just like in 3A, they will ask you to find the derivative of a point when you only have a table. And that point falls right in between two coordinates on that table. The other average is average value. So that's when we integrate some function from some bounds, but we got to multiply it times 1 over the difference in those bounds. This problem is an average value problem. And I see how they ask things. They want you to find the average velocity. We automatically think velocity is the first derivative, and derivative is slope, so it's average slope. No, it's not. How come? They get tricky here. They say based on this model B from the previous part. If I go back, this model B is the velocity. Okay, so I don't have to take the derivative to get velocity. I already have it. If I want the average value of velocity, average value, and they gave me velocity, I'm going to use the integral. And these are now my x1 and x2. These are my bounds. Okay, so let's integrate from 0 to 10. T cubed minus 6t squared plus 300 dt. And let's not forget, we need to multiply that times 1 over 10 minus 0. We don't have a calculator, but these integrations without a calculator are typically easier. I mean, maybe there's a u sub. There isn't here, but they're easier. T cubed becomes t to the 4th over 4 minus 6t squared becomes 6t cubed over 3 plus 300 just becomes 300t. I want this from 0 to 10, and let's not forget, we're still multiplying it by 1 over 10 minus 0 is just 10. All right? Simple integration. Okay. This middle term is just going to end up becoming 2t cubed. And also my lower bound is 0, so that's all going to go bye-bye. So I've got 1/10 times 10 to the power of 4 over 4 minus 2 times 10 cubed plus 300 times 10. I still have to subtract, putting in the lower bound. And that's 0 to the 4th over 4 minus 2 times 0 cubed plus 300 times 0. That's beautiful because this is 0, 0, 0. Bye-bye. Don't even have to worry about that. What I'm going to do, before I actually do the exponents, okay, I'm actually going to distribute this 1/10 times all of this. And that's going to lessen my numbers. What do I mean? 10 to the 4th over 4 times 10 minus 2 times 10 cubed over 10 plus 300 times 10 over 10. What's going to happen here is these 10s cancel, and I have just plus 300. This 10 cancels with one of these, and now it's 10 squared. 100 is 10 squared times 2, so that's minus 200. This 10, that's times 10. That's not 4.10. This 10 cancels one of these. Now it's 10 cubed, which is 1,000 over 4. Okay, this is 250. A quarter of 1,000 is 250. These combine to be plus 100. And that is 350. And they do not ask us for a label, so I don't give them a frickin' label. Man. So if it were a label, this is the average what? Velocity. Velocity is in meters per minute. Okay? That's what it would be if they asked us. But it is not, so we don't give it. Like we don't give a poop. And we're now done.
Don't forget to subscribe and ring that bell.